Hey guys, page 5, let's do it. Okay, so most classes we started this, but I want to go over it because it's important, okay? Equilateral triangle with side length, 8 times the square root of 15, 8 times the square root of 15, 8 times the square root of 15. Okay, so what would be the altitude? So hopefully you're seeing, oh, that's why I need a 30, 60, 90. If the altitude was drawn in, then that would cut this triangle in half. So the hypotenuse would be 8 times the square root of 15. The short leg is half the hypotenuse. So half of 8 times the square root of 15 would be 4 times the square root of 15. You see, right? That would be half. Just like if this whole thing was 8 times the square root of 15, chop it in half, that'd be 4 times the square root of 15. And now let's do our long leg. So our long leg is whatever the short leg is times the square root of 3. So our short leg is 4 times the square root of 15. And then we need to multiply that by the square root of 3. Okay? So we end up getting 4 times the square root of 45. And I would take that as my final answer. Totally okay there. However, you'd get bonus if you could simplify that because there is actually a perfect in there. So most classes we talked that 45, square root of 45 would be the same as the square root of 9 times the square root of 5, all right? And that is the square root of 9 happens to be 3. So we could write this, 4 times 3 is 12 times the square root of 5. These are both equal in value, but this one's been simplified all the way to simplest form. This is exact form. This is in simplest exact form. Okay, cool. All right, now let's do another 30, 60, 90. Let's say the hypotenuse is 11. Let's find the perimeter. So the short leg is 1/2 times the hypotenuse. So if the hypotenuse is 11, we plug that in, we get 11 halves. Long leg. Well, the long leg is the short leg times the square root of 3. So if the short leg is 11 halves, then we have to multiply by the square root of 3. So 11 halves times the square root of 3. Now, we've been asked to find the perimeter. So the perimeter would be add up all the sides. So 11 plus 11 halves plus 11 halves times the square root of 3. These can be combined, right? 11 and 11 halves. So 11 could be rewritten if we multiply the top and bottom by 2, right? We get 22 halves plus 11 halves. And this is not like the others, so it can't be combined. So we end up getting a total of 33 halves plus 11 halves times the square root of 3. Ooh, that's our perimeter. All right, let's keep going. The conveyor belt, the belt makes a 60-degree angle with the ground, and the distance here is 26. That's the height off the ground of the conveyor belt. How far do they travel? So basically they're saying, how long is the conveyor belt? All right, well, we could do this 2 ways. I think in class we used the 30, 60, 90, 30, 60, 90 pattern, but working backwards. So working backwards from here to here, right? Working backwards, we have to say the short leg is half the hypotenuse, but I don't know the hypotenuse. And the long leg is the short leg times the square root of 3. So we don't know what the short leg is, but the long leg is 26, and the short leg, we don't know. So we can solve for this by dividing both sides by the square root of 3. So the short leg is 26 divided by the square root of 3. So the short leg is 26 divided by the square root of 3, and then we want to double it, right? The long leg is, the hypotenuse is just 2 times the short leg. So the hypotenuse is whatever the short leg times 2. So we get 52 divided by the square root of 3. Now they don't ask for it in exact form, they ask for it as a decimal. So that's totally cool. We can just do 52 divided by the square root of 3. Okay, we get the number 30. Now some students were thinking, could I just use trig? And the answer is yes, you could totally use trig. So if the patterns don't work, we could use trig. We'd label this opposite and this hypotenuse, and we could totally use trig. So many students would probably prefer that, especially if you don't have to have it in exact form. So I'm going to use the sine. The sine of 60 is opposite over hypotenuse, and the sine of 60 would be 26 over x. So to solve this, I'd swap the spots here. X is equal to 26 over the sine of 60. So we can put this in the calculator and should get the same thing. 26 divided by the sine of 60. I get the same answer. Pretty cool, right? So how far do they go? 30 feet, round to the nearest foot. Now, let's convert it into minutes. So we took 30 feet, right? And we want feet to cancel. So we want the 60 foot to be on the bottom and the 1 minute to be on top, because we want our answer in minutes, not feet or feet squared. So 30 divided by 60, right, is 0.5 minutes, and they said round to the nearest tenth in minutes. That's what we got. All right, let's do a few more. These are like the previous ones, so let's take a look. An equilateral triangle with side lengths 4 times the square root of 14. So all the side lengths are 4 times the square root of 14 because it's an equilateral triangle. What is the length of the altitude? Boo, splat. So that means this is a 30, 60, 90. So if the whole length was 4 times the square root of 14, you cut that in half, that'd be 2 times the square root of 14. But we want the altitude. So this is the hypotenuse, this is the short leg, and we need altitude, which is our long leg. So our short leg is half the hypotenuse, and our hypotenuse was 4 times the square root of 14. That's how we got 2 times the square root of 14. Long leg. Our long leg is the short leg times the square root of 3. So whatever the short leg is, well, our short leg is 2 times the square root of 14 times another square root of 3. So we're almost done here. We have to leave our answer 14 times 3, 42. So 2 times the square root of 42. Now let's see, is there a perfect in there? So you can try, we could divide it by 9, no. You can divide it by 16, no. You can divide it by 4, 42 divided by 4, no. So that's actually in simplest form. Good to go. All right, let's do another one of these. We have a 30, 60, 90 triangle. The hypotenuse is 15. So the hypotenuse, or the short leg, is half the hypotenuse. So half of 15 is just 15 halves. So short leg is 15 halves. Long leg is short leg times the square root of 3. So long leg is 15 halves times the square root of 3. So how do we find the perimeter? Well, kind of like the last one, we're just going to add them up. We have 15 plus 15 halves plus 15 halves times the square root of 3. So we can add those by multiplying by 2 on the top and bottom, a magical 2. So we get 30 halves plus 15 halves. And that doesn't combine with anything. So that'd be a total of 45 halves plus 15 halves times the square root of 3. Cool. All right, ooh, another conveyor belt question. So these questions are just alike. It's just another way of giving you extra practice. So it says the distance between the two floors is 21, and the belt makes a 60-degree angle with the ground. How far is the conveyor belt? So hopefully you saw trig. Special triangles could be used, but trig would actually be faster. So let's use trig here, opposite and hypotenuse, right? So the sine of 60 is opposite over hypotenuse. So the sine of 60 is 21 over x. We see swapsies will help us solve. So 21 over the sine of 60. Let's figure out what that is. 21 divided by the sine of 60. 24.248. Round to the nearest foot. So 24.2, so that would just be 24. Now it says the belt moves 45 feet per minute. So we want that to cancel. So we'd put 45 feet on the bottom and the 1 minute on top so that this can cancel, right? Feet cancel. And so let's see how long it takes the supplies. 24 divided by 45. And we get round to the, I got 0.53 repeating. So that would round to 0.5 minutes. That's like last time. Thanks for joining us.